Hi everyone. Welcome to the module 3 of the CH course, and which is on network scanning. So I would just let you know the topics that are there under this module. So we are going to discuss some of the scanning concepts. We'll talk about discovery scans, then port scans, and also a tool in detail called Nmap, which stands for Network Mapper. Then we would discuss some stealth scans that we can do with the help of this tool. And we would also discuss some important options. And there's a little overview on HPing and how it can be used for packet crafting. And there will be a list of tools and that other tools that we can use for network scanning. We will also discuss about SSDP scanning and how it is beneficial in finding out the vulnerabilities and the other devices on the network. Then we'll discuss some techniques on which help us evading the IDS and firewall. There will be some small descriptions on banner grabbing, and then we'll discuss the topic called scanning pen testing. So, what actually are the objectives of scanning? Because we have already covered like all OSN techniques, which helps us in discovering about targets. We actually discussed about finding subdomains and various IPs and all that. We discussed about finding persons, then various probably codes that we can have a look at. So that was actually done to find out or focus on a list of targets that we would like to further work upon. So scanning actually takes care of that. It helps in discovering live hosts. It helps in discovering operating system and the system architecture. Then various services and those services that listen on what kind of ports. And if these particular services have any specific versions, and so that we can actually map them to the vulnerabilities or the exploits that are there, which can be used against these. So if we discuss about network ports, what actually is a network port? That there is a slide actually about it later. But generally speaking, it's like any process, if it is present on the network, and anything that needs to communicate with that process, it is it listens on some kind of a port, which is identified as a number. So what generally happens is that server listens on a well-known port for incoming connections, and those incoming connections, I mean servers actually listen on some standard ports which everyone know about. And whenever clients want to connect to a server, they locally assign a port dynamically and try to make a connection attempt to the server. So what is actually a port? It's actually it doesn't have any technical meaning other than that it is just a number to which a particular process is listening in an operating system. So in an operating system, there are around 2 to the power 16 ports. So starting from 0 to 65,535. So if you calculate the numbers, but 0 is not being used by any program. So all well-known ports which are there, they are between 0 to 1023. So if operating system assigns some kind of ports for their own applications which are present in operating system, and they are registered and actually reserved, So these ports lie between 10242 to 49151. And if there is a client side app which needs to communicate to a remote server, then some ports are left free because a starting connection from a client needs to assign itself to a particular port. Only then it can connect to a remote server on a standard port. So these are some you know standard port numbers and services. So if there are some FTP services that are running on a particular machine or a server, they would run on port 21. Secure shell runs on 22. I hope you understand that it's like a normal department, or a government office probably, or any bank office. You go, and there is a window number assigned to different purpose. So if you want to do FTP, go to port number 21. If you want to do secure shell, connect to port 22. If you have to do something with telnet, port 23. So this is more of a standard, and which is known to everyone on the internet. Okay, so anything that needs to be deal with the DNS, whether you are using TCP or UDP as a protocol, then port number 53 is used. Similarly, for HTTP it is 80, POP3 it's 110. For Unix port mapper services it is TCP and UDP. So when you actually scan a target, some of the port numbers make it quite easy to determine whether which particular operating system we are trying to connect to. Say 135 if you get, or 139 you get, it means definitely it's a Windows. So there are some additional. For IMAP 4 it is 143, for SNMP and traps it is 61 and 62, 161 and 162. For LDAP services it is 389. For applications talking on HTTPS it is 443, and for remote desktop it is 3389. And for authenticating users in Microsoft network, it is 445. Now let's discuss about TCP three-way handshake. So what happens is, like, if there are two parties who want to talk and they are talking in TCP, so how the actual connection happens between a client and a server. So first, a client sends a SYN, and this is just a terminology, so don't get confused by it. So I'll let you know that what actually SYN and ACK are in a TCP, or let me just take you to a particular link that I have on TCP three-way handshake. So as you can see that we have two parties. Let's say one is called a client and one is server. So what client does is it sends a SYN, then the server responds with SYN and ACK. ACK stands for acknowledgement. Then as soon as client receives a SYN ACK, it sends an ACK. So generally these SYNs and ACKs are sent with the additional sequence number, and normally TCP initializes it with the number 0 until and unless there is an application which assigns a random number as a sequence number. So as soon as there are these three steps happen, then the connection actually gets established between client and a server, and further communication takes place. So not to know much more details about it, you should just be aware that a three-way handshake is there when the TCP whenever we talk about TCP. Okay. So then you should know that what a TCP header is and what are the different flags. So the terms that I was using about SYN ACK and SYN plus ACK, they were actually the flags inside the TCP header. So let me show you a picture of a TCP header, how it looks. So as you can see that anything below the last block is actually data, and about that data, when it is sent on the wire, especially in the under TCP, it is padded with this information. So what is there, as an information and how it can be read? This is just a diagrammatic representation of that. So you have a source port, you have a destination port, then there is a sequence number, then there is an acknowledgement number, and you can see that there are various flags like CWR flag, EC flag, urge flag, ACK flag, push flag, and then on the right hand side you see there is a window. So this whole header is actually of 32 bits, and this diagram shows that how many bits are being used for what purpose. To generally read more about it, you can actually Google it and read more about it. But how this particular information is arranged in a header, this diagram only shows that. So for packet crafting, you can use a lot of tools such as Nmap, HPing3, NetScan tools, VANKiller, and WireEdit. So this is just one example that I have given below, which is of HPing3, wherein mine TAC F stands for setting up a fin flag. TAC C stands for how many number of packets you want to send. Then TAC P stands for what is the destination port. TAC S stands for what is the source port. So as you remember, whenever an application as a client wants to connect to a remote server who's listening on a standard port, it dynamically picks up a port number and then connect. So two programs have to connect port to port and establish a connection. If they are talking TCP, then they have to establish three-way connection. I mean three-way handshake. And then there is a IP of the target that we are trying to send a packet to. So, as per as like normally, whenever we discuss about scanning the networks, we discuss about IPv4. Oh, wait, let me check. Did I skip any slide? No. Okay. So, as I showed you earlier, that it was a 32-bit packet that I showed you, was it was related to actually version 4 of the IP. And as far as addresses of IPv6 are concerned, they are actually 128 bits. They occupy 128 bits. And normally, the traditional scanning techniques that we use are not feasible for such a large address space. And some scanning tools do not support scanning these kind of networks. So we have to actually collect information about these addresses from the recorded logs or some headlines in the emails or probably from some forums and newsnet messages. Now, once we find out a particular target and we get an entry into a host, then laterally probably we can move and find out other addresses related to a particular host. Maybe IPv4, there is a interface which has an IPv4 assigned to it. So various techniques are there for scanning and they are based on a protocol. So you can actually scan using TCP. You can establish a full connect scan, like if all three steps which were there taken and to establish a connection, then it is called a full scan. Or you can use stealth TCP scanning methods by doing a half open scan. Or you can initiate inverse TCP flags for scanning. Like there are scans such as Xmas scan, which actually sets all three flags at one time. It's actually very interesting. It says that it's quite urgent and push me into give me the priority and push me up the stack, and then it says okay, I'm done with it. So it is quite a weird uh, you know a kind of a scan, which is also called Christmas scan because it lights up the whole package. Then you can do fin only set up a fin flag as I showed you in the TCP header. It's there. Yeah, these are the flags. So if one particular, there is one more diagram I have where say, suppose you are capturing packets on the internet and you're sniffing with the help of a tool called Wireshark, then there is again a representation that you can have. You can have a look like how those values actually look. So this is a diagram, I mean, a screenshot of the capture from a Wireshark tool. You can see that how various flags are mentioned, and was actually initiated as a SYN scan, or a packet actually set a SYN flag, and if you set multiple flags, then those values will be stated as one. Okay, you can see that how source port and the destination port is being captured. So application dynamically spinned up a process at port 41417, and then it was trying to do 23. Means it was doing some, I hope you remember, 23 for telnet. Okay, so and you can carry out idle or IP header scanning in one of the techniques, and you can also do UDP scan for UDP network services by doing UDP. So what happens and what types of scans are there? So generally, first whenever we start with scanning, we actually try to discover the hosts, live hosts, basically who are ready to connect and talk. Then once those hosts are discovered, then we do port scanning, and we try to listen or understand what kind of services and which versions are running on those ports. And then we try to map those services by doing vulnerability scans. So this is something very important that you should know, which is called ICMP scanning. So ICMP echo requests, whenever you want to do whenever you send a ping, it actually sends an ICMP echo request. Now this generally these days doesn't work because most of the people have actually blocked ICMP, and but still if there are times when you want to discover some local devices, and if there is something which you want to determine whether a particular packet will go through a firewall or not, then you can use ICMP scanning, and Nmap can help you in doing that kind of a ping scan. It is also called ping sweep. So what it does is it determines that what hosts are alive, and you can actually prepare a list of IP addresses and send them uh, ICMP echo requests, parallelly or in a sequence. Then only the ones that are live will actually reply. Let's say you are aware of that subnet mask. which is there, then you would probably try to use a kind of a calculator to figure out what all other hosts are there on the same subnet or on the same segment. So I generally use a cheat sheet that I have because it doesn't make any sense to do all those mathematical calculations when the time is less. So beforehand, actually, I've prepared a cheat sheet. And generally, whenever you are given some kind of an IP and any notation, or say cider notation that is given with it, then you should be able to figure out that what is the starting address and what is the end address of that particular subnet, and how many hosts are there, and what kind of an IP can be assigned to those. So say you get access, or one kind of a host replies from one particular segment of a network, then doing using such kind of subnet mask calculators, you should be able to figure out as to what all other IPs and hosts are there. Or you can actually use Nmap requests and various other options which are there for it to automatically do some kind of a sweep to figure out which particular systems are live on the subnet. Maybe I can just show you the kind of cheat sheet that I have. Okay. So it's like, I've noted down all these cider notations and the number of hosts that are there. You say up to 32, I have written all. Generally, you would find that /24 networks are assigned, which has around 256 hosts on that particular subnet. And with respect to finding, host, network address, and the broadcast address, and the subnet itself, you need to follow some kind of a cheat sheet. Now, here I could actually give you an example wherein, say, if there is a /24 network which starts with 192.168.1.0, which is an IPv4 scheme, then I would actually go to this row and see with respect to 24 how many hosts are there. So I would just write 256. Okay. And but because in a network the first address is always taken as a network ID, and the last address is always taken as a broadcast address, so I'll subtract 2 from this, and I would say that on this particular network 254 hosts are there. So based on this information, and as far as subnet is there, then I know that as you can see that it has 255.255.x.0. So this, I need to fill this x. Okay. So with respect to filling this x, what kind of a value I need to put in place of x? So I would actually look down just below the /24 in row 15, and I would note down this number called 255. Then I would write it as 255 dot 255 dot 255 dot 0. And because the first address is actually called the network ID, then I would write this as 192.168.1.0, and the last address I would write it as 192.168.1.255. So I hope you understand. But I mean, this particular information is not supposed to be part of this session. But just to let you know that having a cheat sheet actually helps. So once you figure out a particular IP and you have the information on subnet, how many other hosts can be there, and this information is uh, can be derived from this kind of a sheet. So there are some ping sweep tools also, which can be used, and you don't have to manually do these kind of calculations, and they are more sophisticated in figuring out the value of a mask from an IP address and other information, and they can beautifully lay out all the details for you. So you can use either angry IP, which actually helps you in determining the live host, and it can also resolve host names for you, also determines the MAC addresses, and it can automatically scan ports. And you can use more sophisticated tools from SolarWinds, provided that the tool itself does not have some kind of an issue or some kind of a vulnerability. Because just few days back, I heard there was a news that some kind of a performance management tool which is being used by SolarWinds has allowed hackers to sneak into government departments in US. So just have, if you get hold of such kind of a tool, or if you want to have an opportunity to work with, try to pen test it first and determine whether it has been properly configured or not. So now let's discuss about network mapper. So Nmap is actually a very old tool and was previously also being used by administrators to troubleshoot the network. And there are various, features in the tool itself, which if you get real hang of it, then you might not want to go to other tools, and it is open source. So usually it can be used for drawing a network inventory, and you can actually plan your upgrade schedules. You can monitor hosts on their service uptimes using this tool. So as far as with the respect uh, you know with respect to the attackers, nmap is used to extract information as live host services, then type of packet filters and firewalls that are there, operating systems and their versions. This is one example screenshot that I have given here, wherein the host name scanme.nmap.org was scanned using nmap from the command line, and you can see the result has various ports in different states. So generally you would find open, filtered and closed. So, and the service name is also listed against these ports. So as you can see that it has Microsoft -ds. So probably this is a Windows machine, until and unless they have actually planted a honeypot which actually responds to these kind of requests. So whenever you want to use Nmap, you follow this format. So use write actually Nmap, then what kind of a scan that you want to perform, and various option with it, one or more options with it, and then there is a required parameter called target. So the values that you see in square brackets are the optional values, and the one you see within greater than and less than symbol, that is the required parameter for the command. So what purpose you can use nmap for? You can do host discovery, you can discover ports and services, you can fingerprint or operating systems and other services, you can do a little bit of enumeration. Now it is the next step. Sometimes a little part of it is performed along with scanning. Then you can do MAC address detection. Also, you can detect for vulnerability and exploits. And its syntax is not that strict. I mean, you can first write the target and then you can specify the types and options. or you can specify the target in the end while you are writing the command on the command line. So say if you want to basically scan a specific IP address, then you need to just mention the address of the or the all uh, you know numbers which actually identify a particular machine in the IP. And then if you have a host name only and you don't have the IP, then you can specify that also. And you can specify using the CIDR notation or regular expression, or using the host name and the CIDR notation together, you can scan the entire subnet. Okay, and you can actually use tags, and starting and ending IPs can be assigned, and you can actually specify a range or a specific host along with it by separating it with the comma. So as part of discovery scans, you know, what kind of things are done? You know, a ping sweep is actually done in a network scanning method, which uses ICMP echo request packets to search for the hosts. And most of these scans, they use ARP instead of using ICMP. Why? Because ARP generally asks for, it broadcasts in a particular network and says that, hey, IP this and this, what is the MAC? And then it usually bypasses the firewalls and generally allowed in a network, where an ICMP is not of that much of use. So that's why people have started blocking it. So you can use TAC-PR to send these ARP requests in case of Nmap, and for on whether for any Nmap scan you can use it. Even if you don't, then it is a default discovery method that is used by Nmap. Or you can use TAC SN, so which is actually which is the combination with ICMP echo request TCP SYN to port 443, TCP ACK to port 80, and also the timestamp request. So with the tag SN, there will be no port scan. It will just going to see whether a particular host is alive or not. So various Nmap scan types that are there. If you while actually scanning a target, if you want to enable debugging and you want to all view all the steps that are performed by Nmap, then you can specify tag D. Or you want to do only a SYNAC, you can use tag small s and capital S, and you can specify the target. If the port is open, it will be responded with SYNAC. Otherwise, it will send back a reset. So RST is actually the reset, the flag. So if you, as a non-root user, if you want to uh, do a complete TCP three-way handshake, then you can specify capital T along with the tag S. If you want to probe a particular host for various service versions and open ports, then you can specify capital V. So it would actually list down all the services along with others on along with the port information on which they are running. And if for a UDP scan, you have to mention capital U. So with respect to UDP, you should know that a client would never come to know whether a particular packet reached a server or not. So it's just based on trust that uh, it has to be only I remember only ICMP not reachable error sometimes, which comes back from a server, and which is a type code 3. So you would come to know that probably that particular port was closed. Otherwise, in case of a UDP, it's a little difficult. So if you just want to list the target, then you can use capital S, capital L along with small s. And if you want, to find out that if the host or a network is protected by a firewall, you can just use capital A with small s. So if you want to determine if these have any accessible ports and actually they are open or not, then you can use tag capital A along with the small s and a. So some of these stealth scans, because again, I've given the example with tag s and capital S. So it will just send us TCP SYN. It won't complete do a full handshake. So as soon as the server would respond SYN ACK, it would actually send a reset, and it will close it, saying that, oh, something like, okay, I want to talk to you. Then as soon as the server responds, it says, "Oh, okay, I was just joking." So it is also sometimes called half scan. Then with capital A, if you want to send, then it is going to send TCP ACK before. I mean, just to map out the firewall rule sets. Generally, it happens that you get a SYN and then you send an ACK. But directly, if you send an ACK, then firewall may not respond properly, and it will help you in determining which ports are filtered, and would also check that the firewall is stateful or not. Then there is called null scan, okay, which is like with capital N. It is not the proper way of actually setting up flags in a packet and sending it, but still sometimes it is used, okay, because it helps in sneaking into a non-stateful firewall. So if you explicitly want to do a TCP fin, then you use capital F with small s. And for doing a Christmas scan, you specify capital X. For skipping the discovery and assuming that all hosts are online, you don't want to, you are just assuming, okay, and you want to scan all the hosts for all the ports, all 65,535 ports. Then you specify tag p tag, the small p tag, and then to assume that all the hosts are online, you say tag capital P and small n. So if the firewall is up, and they offer only usually unusual ports, then this particular stealth scan is useful. So say you have you know a machine in between, and you don't want to let the IDS detect that from which source a particular packet has come. Then you can actually specify that with a -SL option with zombies from which you want to relay a particular scan. And before you can mention that before mentioning the target with the tag SL option. So this similarly you can use -V and -B for doing FTP if the target is FTP target. Okay, but many vendors have actually blocked these kind of relays. So what it does is like it would first do an FTP to some kind of a zombie again, or an IP which is being used as a relay, and then that particular request would go to the actual target. So for controlling the speed of the scans, you can use -T option. So wherein 0 stands for slowest and the T5 actually stands for fastest. So generally it is recommended to leave it as default, which is T3. But in few cases, if you want to control the speed, it is recommended to use T4, which is also a fast scan. So try not to use T5 because generally it is picked up by IDSs because it is too fast and it's called insane actually. Then if you to evade detection, if you want packets to be fragmented, in 8-byte fragments so that it is difficult for IDSs to understand the signatures of the packet, then you can use -F option. And if there are multiple uh, decoys that you have deployed between yourself and the target, then you can use them as a list as I have specified with -D option with Nmap. So what it does is it helps you in creating some bogus packets, and these packets actually go and blend in with the other packets, and it appears that the actual traffic is coming from these decoys rather than your source machine. Some additional stealth scans. I think I have mentioned already. Yeah. So if while doing a scan, if you want to specify that from which network interface you want the request to go, then you can specify that with -E and name of the interface. As you know that a machine can be connected to multiple interfaces at the same time. Okay, with capital S and the name, you can spoof, the source address. So it is usually to, it might not be very useful in your reports, but it can confuse the IDS that these requests or these packets are actually coming from this address, this source address, rather than yours. And if you want to specify, any random MAC address from a vendor, you can use my double tag spoof MAC with a capital P and an option. Okay, or explicitly you can specify a MAC address as it is shown on the slide. Then to spoof a port, you can use double tag source port option. Okay, and you can specify 53, the port number, and then the target. Say if there is a range of hosts from starting from 1.1 to 200, okay, and you want your scans to Nmap, you want your Nmap to randomize these scans. Okay, then you can specify a randomize host option. If there are multiple proxies that you want to use in between yourself and the target, then you can specify them and with us by separating them with a comma. So it will help you in relaying the TCP connection through a chain of these proxies, and generally it is useful on internet. So let's discuss some of the Nmap options. So with the TAC-P, you actually specify port numbers. You can specify multiple ports by separating them with comma. And whenever you want to mention a range, it is best to specify them with a dash. And notice that there is no space while mentioning this range. So if you want Nmap to perform separately UDP and TCP, requests on ports, then they can be specified or separated with, in this manner. And if you want to Nmap to search or look for all the ports which are there, then rather than specifying other explicit options, you can specify tag small p tag. Generally, the scans are conducted randomly. Okay, but if you want Nmap to perform those scans consecutively, starting from 1.1, 1.2, 1.3, to all 256 hosts that are there in a particular subnet, because here I've stated as /24, or rather 254 hosts, and you want Nmap to actually go in a sequential manner, then you can specify tag small r. If you want to specify or top 200 ports or whatever number you want, then you can specify this option, top ports For IPv6 scans, you have to specify tag 6, and then you can give the MAC address, or sorry, the IPv6 address, or the host name also can be given. So let's say you have list of hosts in a file, and you want Nmap to pick up from that file, then you can use small I and capital L, and then you can specify the list, name of the file. So it would one by one it will start scanning those targets. And these options can be combined with other options that we have discussed. So it depends on what kind of a requirement you have. So you can try combining these options uh, on your own. So if there isn't a particular IP in a range that you want to exclude, then it can be excluded with this option, double tag exclude. If you don't want Nmap to resolve DNS names for you, because generally it takes a little bit of time, then you can specify tag N. And if you want it to mandatorily resolve a DNS name for you, then you can specify tag capital R. If you want Nmap to do pick fewer ports, I don't know which default ones it generally would pick, but then by default it scans for 1,000 top ports, but you can reduce the number, or you can do fewer port scans by tag F. And if you want to enable OS detection, which is usually not accurate, not very accurate, so you can specify tag capital O. So in your scan, if you want to enable OS detection as well as service version detection or script scanning and a trace route by whatever default script that it uses, NSE like Nmap scripting engine uses, then you can specify that capital A along with it. Let's say if you want to aggressively ask Nmap to probe for the level of version, the level of intensity with which it should actually seek the version of services which are running on a target, then you can specify version intensity option with a number which lies between 0 to 9, wherein 0 stands for light and 9 attempts all kind of probes. If you have some kind of scripts you want to make use of, then those scripts can be used with the help of double tag script and the name of the script. If in the scan, if all default scripts you want to use, then they can be used with the capital C option along with the small s. And if you want Nmap to be very, very verbose while doing this scan, it will log all detailed messages, then you can use double V option. And to save your outputs, if you want to save your output in a normal format or an XML format or script kiddie format, and there's one more grippable format, then you can specify those options. Like you can specify N for normal, X for XML, S for script kiddie, and G for grippable. And if you want your results to be stored in all of the formats, then you can say capital A with small o. So for packet crafting, this slide was already there initially. So if you want to send a fin packet, a packet with fin flag set and one packet to a destination port of 79 from the source port 5150 to a particular target, you can also use hping. So all other host of tools are there. So you need to actually check yourself that which tools you are comfortable with, and it takes a little bit of time for you to get acquainted with it. So some of the hping commands that are available are ICMP ping, you can do an AXScan, you can do an UDP, You can actually initiate a give a specific initial sequence number also. So you can do firewalls and timestamp commands. You can do a syn scan, and this is just an example on port 80, but you can specify other ports also. Or you can do a Christmas scan again using hping. You can also scan the entire subnet for live hosts, and you can intercept the traffic in between, or you can simulate a denial of service by doing a syn flood, a target. Yeah, this hping is another tool other than Nmap, and all similar operations can be performed with it. So there are some additional tools that are there other than Nmap and hping that you can make note of. So there's the OmniPeak, then there is network scanner, mass scan, which are quite popular, megaping. Okay. So for mobile devices, these are some of the tools like IP scanner, Fing, Hackcode, Csploit. So these tools might have changed their names or recently. You can have a look at it. So as you know that normally in a home and office environment, we have a lot of devices, and they make use of UPnP uh, architecture, and which actually runs over, you have SSDP as a protocol, which runs over HTTP, a modified version of HTTP on UDP. Then you have SOAP and Jena, okay, which runs on HTTP and which is on top of TCP. And this all is all stacked on IP, which is like Bluetooth, Ethernet, or Wi-Fi. So what is SOAP? It's something like a, some kind of a common standard, which is used to exchange information in a structured way. So generally, you would see that they are used. These SOAP protocol is used to implement web services in computer networks. It has allowed things to be more extensible, neutral, and independent. And it is a message format which is written in XML. Okay, and more it relies on the application layer protocol, most often the HTTP and not SMTP. SMTP is the mail protocol, mail transfer protocol. So in an operating system, if there are different operating system also are able to communicate between among themselves using SOAP. So all these home devices that are there, they have to immediately come in contact with each other and work to provide the features. So they make use of SSDP. So all these plug and play devices there on the network, you can do SSDP scanning to discover vulnerabilities, and you can further launch buffer overflows and denial of service also. Also, you can check which machines can be exploited, which are not firewalled and which are firewalled, and it can be used for both IPv4 and IPv6. Some of the techniques to evade IDS and firewalls are mentioned on this slide. So you can fragment the packets, you can reroute, or you can mention different sources in between. You can deploy decoys, you can spoof the IP addresses, and you can make use of proxy servers in between. Some of the countermeasures that you can use to thwart IP spoofing. So it's better not to rely on IP-based authentications. Always encrypt all transmissions, make use of firewalls, and understand ingress and egress filtering properly and make use of that. Then generally, I said that TCP starts with the sequence number 0, but applications can actually randomly assign initial sequence numbers so that others cannot guess it. And then other SYN flood countermeasures which are there, they can be deployed to thwart IP spoofing. or you can use various load balancing methods to distribute if in case of denial of services. So what actually are proxy servers like? It's like if there is a source, a client, and there is a destination, and there is some kind of a problem in between, and there is a requirement of an intermediary, then these proxy servers come in picture. So generally you would see that what happens is that behind a firewall, if there is an office, let's say, and behind a firewall internally you would actually have a server which will take the request from a client and would hold it for a moment and would say, okay, what you need. Then it would make note of it. It will go on the internet, fetch that content for you, and cache it for a little bit of time, and then serve it to you. So it has cached it so that if other clients want the same kind of a request in that particular subnet or a network segment, then it can serve the same content to them. So this is a normal use of a proxy. Say so that internet traffic which goes in and out of a particular environment can have some kind of a control. So, but attackers actually use it completely for different purposes. They use it to avoid discovery and achieve the objectives of hacking, or they use it for impersonation. As I already showed you various scan types and options using Nmap, which is possible. You can yeah, they actually want to remotely access a website from a protected intranet, then proxies can be used. Multiple proxies can be chained together to avoid detection, and even sometimes to reroute users to different destinations, proxies can be used. And on the internet, proxies are available in thousands, actually. If you So what generally approaches you would have? So you have edge proxies, you have anonymizers, you have proxy chaining. So as you can see that there is a school PC which wants to connect to Facebook on the internet, but firewall actually is blocking it. So people make use of proxy servers so that it can fetch the content from the internet and serve it to the school PC. So some of the proxy tools that I have mentioned on this slide, such as proxy switchers, proxy workbench, Tor, CyberGhost. You can have a look and read through it on the internet. You can find about them. Okay. Some additional also tools that I have mentioned. Probably in your office environments later, you could make use of Burp Suite and Charles. And sometimes I've seen people using Fiddler also. And for mobile devices, these are the ones that are listed: CyberGhost, Shadow Socks, Server Ultimate. You know, some of the anonymizers. So if people want to use anonymizers to, evade detection or sometimes hide themselves, these anonymizers can help them, and sometimes to bypass censorship, you can make use of these. And there's like Tunnel Bear, Tails. Tunnel Bear is there on for phones also. Then there is Ultrasurf, Guardster. uh, So in case of proxy chaining, you actually have more than one proxy before a request can actually go to destination. Okay. Generally, it follows step-by-step process that client requests resources from the destination. Then the request is passed to a proxy server. Proxy strips the ID and passes that particular request to the next proxy server. And this process is repeated until the chain is complete. And at the end, a request goes in clear text. to the actual server, the actual target. So how Tor works. So in this diagram, you can see that Alice wants to, let's say, connect to Bob, which is at the other end of the network. And what it would do is, what she would do is like, it would get the list of Tor nodes from a collection of servers in between. Say a system has helped her to uh, keep these nodes, say these nodes are alive, and it would probably go to, this, say one of the node is machine. So let's say a node is the starting node, and there's one node which is a finishing node or exit node. Then any path can be taken by a request to reach the actual target, which further helps um, evading any tracking or a trackback that can happen to the requester or the source from where the request came. So let's say LS starts one particular session and stop in between, and then after some time she again connects, wants to connect and talk to Bob. Then the request would follow a different route altogether. Okay, so say it would randomly pick one starting node and one exit node, and it will be relayed randomly with the help of these green links that you can see. And but just remember that anytime the traffic is exiting from this collection of nodes, then it would be in an might be unencrypted if there is no encryption in between the exit node and the actual server. So what is banner grabbing? So if you want to identify services by sending out some kind of a message to a server, then these services generally talk about themselves. Okay, they themselves give you the information as to what they are and what they can be called and what more is available. You know, so you can if say you sent a wrong request and it replied with an error message, then it reveals other additional information with it. This kind of a additional information which comes along with it is called, or capture of this kind of an information is called banner grabbing. So you can also examine TCP and ISMP message to identify operating systems by making use of these techniques. So it is of two types, active and passive, and others. So as you can see, you can specifically craft a packet which can be sent to a remote OS. And if anything which you are any step that you are taking to actively interact, or modify a particular packet would fall under active. Okay, you want to probably send different responses, uh, or sometimes operating systems have a different TCP/IP stack implementations. So maybe you would get different responses from different operating systems. Then for under passive type of a banner grabbing, you can do that from error messages or some other log messages, or other underlying information which is available. Then if you are sniffing a particular network, then from there you can get information on server types, OS types, and SSL tools that are in picture. Or you can capture and analyze packets from the from understanding the page extensions. Say there is a website which is written in active server pages, then it would use some kind of an extension in the end, say .asp. Then you can say, okay, so there must be an IIS running on this machine and it's a Windows machine. So these kind of interpretations you can do from banner grabbing. Now, you would normally classify this particular activity under enumeration, but a limited amount of it can be used under scanning. So this is just some additional information. Then many tools are there for grabbing the banners for you, and these are the services which actually are there, which let you know that they are running on particular standard port. So FTP, SSH, HTTP, all of them can be queried using these techniques. So some sample commands I have given below. So you can say telnet and you can specify the target IP and a port number, or you can use netcat with the very verbose option, or you can actually combine uh, commands like grep, netcat, and echo together to send a HTTP GET request. Some of the banner grabbing tools are also there, such as IDserve, netcraft, netcat. I have already mentioned netcat. So there are two versions, like NC is another binary and netcat itself is another binary. So with the netcat, completely if you specify, you can do SSL, but with the NC you cannot. This is just a, the netcat is more advanced version of NC. Banner grabbing, some countermeasures that you can apply. You can disable or change the banners, or you can place some dummy banners to hide the information. You can turn off some unnecessary services. You can use server mask tools to disable or change these banners. And just example of a configuration of Apache is given here. So similarly, if other applications have some configuration files which can reveal information while someone is doing a banner grabbing on your server, then you can modify those in the configurations. And then you can actually use tools like page exchanger in IIS to manage to hide these extensions such as .asp and .htm. So for conducting a pen test scan, so as part of pen testing, you can do these scans because they help admin to identify that if there are some unnecessary ports and services and banners which are there, uh, some stringent measures can be taken against them. And also, you can tune the firewall rules and troubleshoot various configuration errors by doing such scans. So, if there is a network and there's a high level view which is uh, given to you in a map or in some kind of a diagram, then that is considered as topology maps. So, there are various tools which can help you in drawing these maps. One example is there. So, this is a diagram of a wide area network wherein you can see that there are various routers and there is an internet. Then there are various routes that are there and assigning IPs, a visual representation of these devices physically, a logical representation of all the physical devices that are there in a network. So those are actually displayed in a topology map. So as part of penetration testing, when you do scans, they are actually very important from the perspective of organization's security posture. So you under that you actually do these scans and do give your recommendations. So while you are doing and scanning, vulnerabilities, you identify live systems, you discover open ports, discover services that are being used, and you can test the system for banner grabbing. Then you can recommend that which ports to be closed and which are all unnecessary services, what all information can be hidden from the banners, and what all service configuration errors that you received. And then you can collect that and give it to your internal teams for them to correct those things. So we have come on to the end of our lecture. I'm in this session wherein, as part of network scanning, you first discover all possible targets. So which can you can discover live hosts, you can discover open ports, you can find out about protocols, you can detect services and OS versions, you can perform it actively or passively. Also you can include with banner grabbing a little part of it, which is actually part of enumeration. and then you can manipulate and craft the packets. So crafting the packets is nothing that you have to do something from the scratch, but you have to just apply various combinations with the options that I already gave it to you. So by doing that, you can probe for open ports and you can test your firewalls and IDSs. And additionally, you can make use of anonymizers and proxies to hide, uh, the sources from where the packet is traveling on the internet to the target. So this particular session is complete.